It finally happened. Finally have my very own 12 volt high power / 12 volt 2x6 melting connector problem, although it's barely melted. We're gonna talk about this today and fixing behavior or how we're gonna fix it and move forward. But it finally happened, and it only took me hitting this thing with 1200 watts of power repeatedly over and over and over again to get the problem to even start. But this card saved itself. And this is like, I think what all brands kind of have to do moving forward with the 12 volt high power connector. And as much as we've given Asus a lot of shit over the years, which they absolutely deserve, the design of this board deserves praise. And I'm gonna give praise where praise is due. Today's video is brought to you by our brand new GPU Apocalypse 2.0 shirt, kind of immortalizing all of the stuff you love about today's GPUs. Our GPU Apocalypse 1.0 shirt was actually one of our most famous and popular shirts, and now it's re-immortalized with GPU 2.0. But let's face it, the Apocalypse never went anywhere, it just evolved. Just like this shirt. Go buy it now. Okay, so this is the 5090 Astral, if you guys aren't aware. This is the card that is currently number 3 on the leaderboard in Port Royal, number 8, I think, right now in Steel Nomad. I haven't really focused on Steel Nomad, but that's besides the point. The Astral card is unique, and I need to preface this. I hate that I have to say this over and over and over again because I guess it's commonplace for anyone on YouTube to be making videos sponsored by blah blah blah. This is not sponsored by Asus at all. Okay, I bought this card. This is a purchased card. But I bought this card for multiple reasons. One, when it comes to the XOC stuff, the power phase design in this, actually for Buildzoid had even mentioned like the power phases in this card are even beefier than any of the other like 5090s and custom 5090 cards. Like these are 80 amp phases instead of 60 amp phases, which you find on like the Gigabyte Aorus Master, which I flashed that BIOS on, remember? In fact, he had even commented on that video saying like, I probably wouldn't run that card with that BIOS for very long because though the amp design and those power phases are not going to probably last very long. Now, I am sure, I'm quite positive I have far more than 100 to 150 runs on this card under liquid nitrogen with a power limit that is, what, 600, 1200, almost 3 times the limit. Because 1600 watts is what this thing is able to pull with XOC modifications done to it. So, you guys remember recently I soldered this on right here, which allows me to take control over the voltage controller, which is actually that chip right next to it, where I can then go in and adjust like the load line calibration. I can make it sooner, more voltage sooner. I can make it more voltage later. I can spread out that voltage. I can control the voltage offsets, positive, negative, for both memory as well as the core. So everything was going pretty well. But in the most recent run, I was like, man, I really want to make a run for an OGS. I want to go for second place, right? I was so close, less than 300 points away, and it's fine. I cranked the voltage on this guy. And when I say crank the voltage, like by default, this card was pulling about 1.22 to 1.25 volts under load at over 3,500 megahertz. And when we talk about amperage or power draw, I was seeing anywhere between, on average, 15 amps per pin, which is significantly higher than the 9 amps per pin that it's actually rated for on the 12 volt connector, with spikes as high as 20 to 21 amps per pin. That is insane. Because of the fact that using something even like Steel Nomad instantly hits the card at like 1200 watts to 1250 watts and then kind of comes out. Like if you've ever monitored the power draw on Steel Nomad, which clearly I was doing a very robust monitoring system on this so I could keep tabs of that, it would absolutely, like the second the test starts and he's like right in that speeder, it's like 1280 watts and then it drops down. It's like something about that instant start. And if you've ever had your test crash right at the start, it's probably because of that power spike and an instant throttle on voltage, which then throttles the card. And if it can't if it can't adaptively adjust its frequency fast enough, it can crash. I did one, so the other day I did one run on Steel Nomad and it crashed right at the end. And I'm like, dang it, and got back to the desktop. And then I poured more LN2 in the pot, brought the temp back down, and then said, let's go again. And as soon as the test started, it crashed, and then black screen. And I was like, oh, damn it, thinking maybe there was water in the in the card. Now, when you have the XOC stuff on here with the liquid nitrogen, even though I'll use Knead Eraser all on the RAM chips to try and keep them dry, I have heat sinks on like the controllers and such. Got big heat sinks that I made for the VRMs. Water still accumulates. And even though there is a small conformal coating on this, water can still make its way into things like under the RAM chips, specifically back here, because it'll kind of freeze through the board. And then back here will get all frosty, and then water starts to get under like the POS caps, and then that's it. You know, it will start crashing. You gotta warm it up, dry it out, blow all the air out, use alcohol, displace the water, dry it out, put it back, off you go again. It can survive being literally waterlogged. It's surprising how much water these cards can handle without dying. But, so I thought that's what happened. When I went to tear down and take the plug off, it wouldn't come out. I'm like, oh, I know what that means. Now we got really lucky in the sense that only one pin was showing any signs of damage. We'll take a look at that under the microscope right now, and we'll talk about the design on this card that absolutely deserves praise and explains why some of the price premium is on here. It doesn't explain $1,300 of price premium over like a Founders Edition card, but I think it's about the only way that you'll be able to, in the future, really with these high-powered cards, and who knows what the 6000 series or whatever they're calling it will bring power-wise. I guess unless they increase the spec of the cable or do too, there's no way they can really exceed this at this point. But this card was able to save itself, and I'm thankful for that, because I can replace this plug now and get back to running again. Like, this card is relegated to either break records or die trying. That is the only thing this card is going to do around here. So, I mean, looking at it, it really doesn't look that bad. Like this top left one up here, that's the one that's got some of the melted plastic on it. In fact, the only reason it's even shiny at all is I did try and see if I could like scrape it off, maybe make a connection and then it will work again. Because you can see there's absolutely no melted plastic on the GPU side, but it is not making a good contact. Like if I turn the angle a little bit, it is not making good contact with any of our plugs like I've tried already. So it doesn't look like there's anything wrong with it. But if we drop the light down, now you can see, right, that pin is definitely a lot less shiny, because that means it's coated with stuff. And that stuff being plastic from the adapter. Now, if you recall, I've been using this adapter the entire time. And the reason for that is I definitely wanted, in fact, I didn't check this end. No, we're good here. I definitely wanted 4 PCI Express 8 pins feeding the card. Because if I was only using like 2, like the Corsair one or whatever, you know, up to 12 to 1600 watts, it's never spiked 16, but maybe transient spikes could. But anyway, the measurement on the voltage controller never really showed that it was pulling more than about 1200. I'd be concerned with 2 8 pins for that, so I wanted all 4. But let's look at the plug side, because if you look at it from here, you can see, even right there, like there is a non-shiny part in there. But if we look at this side closely underneath the microscope, you can see that sucker definitely started melting, right? So that's where the transfer came. It came from this plug right there and transferred, like the heat kind of melted the plastic into the pin, and then it just started flowing, if you will. And then what happened is, fortunately, because of the design of this board, what happened is as soon as that pin no longer was making good contact, it means that pin and that ground no longer was completing the circuit going to the power delivery system of the board. Now you might be going, but that doesn't make sense, because most of the cards are just using a standardized bus where those pins just go to a solid bar that goes into the board. And if that were the case with this card, then it probably would have kept running away temperature-wise to get hotter and hotter and hotter. And then because that pin would no longer be making contact, all of that voltage, all that wattage, and all that amperage would now be divided amongst 5 pins instead of 6, which would then make it get hotter and hotter and then start melting across the board. The reason why that is not the case on this card, this right here is the power delivery system. So the side that has the bad pin is actually farthest left right here. So we've got a power and a ground that go through its own shunt that go into the rest of the power delivery system. So the GPU itself is requiring that each pin, 12 volt and ground on the 12 volt high power, be completing a circuit into the power phase system. So once that no longer made good contact on the positive side, it killed this circuit, which means the board recognized, hey, we lost a power delivery phase through here. And because each one of these shunts represents each one of the 6 positives and negatives. So that's separate, that's separate, that's separate, that's separate, that's separate, and that is separate. Whereas if you look at a lot of the 12 volt high power designs, all of those pins just go into a solid bar. Because the idea initially was that maybe each pin couldn't handle the amps that, you know, the 9 amps that is designed to go through each one of those pins independently. So some brands started sourcing plugs where they're just a single bus bar behind, so they're pins that solder into a bus bar. And then if that pin no longer is making good contact because it melted or broke or whatever, then the power just continues to travel through the bus bar into a dummy system into the card that just says, hey, I'm still getting power, I'm still gonna run, but it's not independent, it's not intelligent enough to know, hey, there's something wrong here. So what happened here is when something went wrong, this no longer was sending power to the power delivery system, so the card shut down. And that is a design that I think is worth it. And I mentioned this before, if I was gonna run a 50 series in my personal rig, which I am, and we'll show that in a second, I'll actually demonstrate a pin that's getting too much power or too much amp through it, and what the card does to kind of warn you and tell you, hey, something's not right there. But this design right here alone is, like I said, I need to give credit where credit is due. Asus is the only company so far that has come up with an independent power delivery system like this to monitor the pins. And the cool thing about this, because the board has sensors built into these shunts, ADA64, hardware info 64, any sort of monitoring system, outside of even using GPU Tweak 3, because I don't use GPU Tweak at all from Asus. I don't care for that suite. I don't care for the software. I don't care to have overclocking software, monitoring software running separately from, like, I use ADA64 and a sensor panel, and I was able to actually now put each one of these on my sensor panel so I can monitor these, and I can even have my own alarms and my own warnings set up for that. But it doesn't look to me like, just by looking at this, it doesn't mean there's nothing wrong with them, but on the surface, it doesn't look like anything is wrong with this guy right here, because this is the circuit right here that started to melt. And so everything looks good right here. Nothing looks like damaged there. As long as nothing damaged through the circuit. I mean, even if this somehow died, which I don't think happened, because what happened in our instance was connector got hot, plastic melted, it then turned liquidy and coated the pin, which now has an insulation barrier on there, which is not allowing contact of the metal, which is not turning on that circuit, which is causing the board to not turn on. Actually, the board turns on and shows 0.7 volts, which is funny because normally when it turns on, it shows about 0.84 to 0.89 volts when I start the card. So it's powering on. It's just this circuit is not delivering the power that's expected, which makes sense. The voltage that the board sees is now lower. And the reason why I was able to know that is because, remember, I had this soldered onto it so that I could monitor the voltage. So by me having this on there actually told me, like, hey, the card's not dead. It just has something power delivery wise that's failed. But yeah, so I'm just gonna have to replace that plug and then we're gonna be up and running again, no problem. I don't believe anything physically happened poorly to the card. Now, it's kind of ironic that it took as many runs as it did at the amount of power I was pushing this card through, which is far beyond the spec of the 12 volt system, that it took that much for it to only fail this miserably. And I'm gonna show it again just so we can reiterate. Editing Phil, why don't you go ahead and throw up on the screen right now what some of these failed plugs end up looking like, and the fact that this is what mine looks like. We're really fortunate because this thing should be fully disfigured. And it would have been if it didn't have that intelligent system on there to say, hey, something is wrong with one of our power delivery pins. So that one right there that you can see clearly started to melt would have ended up looking like, you know, those atrocities that you see where they're just completely disfigured and melted and ugly. Let's go take a look at the water block card, the water cooled card I have in my rig right now. So you can see what I mean about individual pin monitoring and how that needs to be the future, in my opinion, for all 50 series cards, at least 80 and 90 series, like 80 and 90 tier. So this is the same card. This is my sensor panel. It's not done being set up. I barely started it right now, but you can see right there under the GPU section, I've got pin 1 through 6 on there. So I can actually monitor the amps that's running through those pins. I don't care about voltage, I don't care about wattage, I care about amps. Amps is what destroys these plugs. And so as you can see under idle condition right now, it's just the typical, you know, Watts divided by volts equals amps, and you can inverse that to determine, I probably even said that wrong, but the point is, the reason why it's only at 0.4 amps right now is because it's in idle condition. Now, if I come over here now and just run Steel Nomad, I'm gonna start it up, you'll see as we go under load, right, the board TDP right now is at 65, or 55, 28. When the test starts, you'll see that we're gonna jump up board wattage to, there we go, jumps up to almost 500 watts or 600 watts instantly, but look at my pin 1 versus my pin 9. Pin 2, 3, 4, and 5 are nearly identical, which is what we're expecting, but pin 1 is only hitting mid 7s. Pin 9 is hitting, or excuse me, pin 6 is hitting over 9 amps. Now, 9 amps is what it's expecting to see kind of across the board, but you can see pin 6 is carrying a little more amperage because pin 1 is not carrying its full load. It should be up in the 8s and pin 6 should be down in the 8s. But you can see right now it's at 9.16. As the card starts to get warmer, it's only at 44C right now, but as the card starts to get warmer, you'll see that what's gonna happen here is, there we go. So we hit 9.22 for a second. And at 9.2, there is a kind of a warning built into the card. So if you look right here on the card, right above the power plug, you'll notice this red blinking light. Now that red blinking light is just sort of an indicator to say, hey, one of your pins or something in the 12 volt high power is out of spec. Now I feel like the 9.2, there we go, 9.22, and it starts to blink as you can see. So I feel like that's a little tight of a threshold. I feel like it should be like 9.5 to maybe 10, because we showed in our cable testing video that some of our pins could pull as much as 11 amps depending on the workload and the wattage draw and all of that. So I don't have the card very heavily overclocked right now. It's only, technically it'll run at 3200 if it's not too heavy of a load. Steel Nomad, which is what I'm running right now under load, is a very difficult test to run, so that's why the clock is dropping like it is. But the thing is, there's also power loss through heat. So as the card gets hotter, you're gonna end up losing more of that power draw through heat, which means it has to start pulling more power to make up for the expected delivered power to the core. So even though it might be delivering, which is showing right here software-wise, 588, 591 to the core, as we've shown with our EVC, not our EVC, but our PMD2 device through Elmore Labs, to deliver 592 watts right now to the core, it might be pulling 620 to 630 watts through the cable. That's why the amps can be higher. So if it starts to get hotter, sometimes it'll pull even more than that. But now you get this red blinking light, which is almost constant now, because as the card is starting to warm up, it is now consistently pulling that 9.22 amps through that one pin. But you have at least a visual indicator here that something is out of spec. Now that's the reason why I said I feel like it's a little tight at anything above 9.2 to start blinking that light, because I have not pushed the power limits. This is the standard stock BIOS. I cannot push the power limits. And even if I run the clock at stock speeds, it will still blink that light. So to me, that's a bit annoying that I can't go in and increase that threshold. But what this is telling me right now is I've already made sure this guy is fully seated, but it has me wondering, do I maybe need to unseat and reseat the PSU side of this cable? This is just an Amazon cable, which is probably one of the biggest no-nos you can do when it comes to 50 series stuff. But it feels to me like I maybe don't have a great connection on pin 1 on one or both sides of the cable, which is making pin 6 carry that, because it has to still math. The math has to add up to the watts that are being delivered. So if one pin is not carrying all of its weight, it's not carrying its weight in amps, something has to make up for it. And in this instance, it's kind of interesting to me that it's not making up for it kind of across the board. It's one pin carrying that excess load. So I now feel like for a good measure, I should probably start keeping an eye on this. Now, what I've done is I've also set this up so that if any of my pins start to exceed 10 amps or 11 amps, that line will turn yellow. Because as you can see, it's a gauge, right? So it moves all the way to the right. I have it set right now so that the max of the actual scale right now is 10 amps. But if it exceeds that, then that will turn yellow. And the reason why I make it turn yellow is the fact that it'll be really obvious against the color scheme in my system. So I can go, whoa, okay, and I can shut down the system before anything potentially bad starts to happen. I have no idea how many amps that pin was seeing to start to melt. But I can tell you I have seen it pull up to 20 amps under our liquid nitrogen XOC 3500 megahertz plus Steel Nomad runs. So anyway, just kind of wanted to share like, hey, you know, it's funny that I can run something like, it's not this exact card. I did XOC this card for a bit, not the greatest clocker, so I threw a water block on there and put it back in my rig. But it's kind of crazy that I can run something like this. You guys have seen my Instagram post with the crazy contraptions I've had to come up with to make it all work and run at those crazy speeds. And I can do that repeatedly for hours on end, hundreds of times, and not get a catastrophic failure. But guys running stock out of the box, touch nothing, plug in a cable, start gaming, get a black screen, and have the thing completely catastrophically fail can happen at stock speeds. But I feel like the reason why you're not seeing many, if any, Astral cards failing that catastrophically is because of the design. Because once one of those pins starts to make a poor enough connection to where it's not sending any more power down the line into the power delivery system, the card shuts off. So it can kind of stop it before it gets worse. Now, obviously that card still needs repair. It did not stop anything from getting to the point to where it wouldn't work anymore, but it did stop it from absolutely like liquefying the plug. But this is the future. And by the future, I don't mean the cool design that Asus did with the Astral card. I mean the fact that this is always gonna be a possibility. And you know, I gotta deal with that red blinking light constantly now. Now here's the thing. For me, this feels like when you drive an old beater car and you got an engine light and you're tired of looking at it, you just put a piece of tape on the dash. I'm tempted to put a piece of tape over that because that's annoying me, to be honest. I know why it's doing it. It's just because it's at 9.28 now. See how it's going up as the temp goes up? So it's not in the danger zone. 9.2 is fine. It's just, I feel like that I should be able to go in and modify that number and give a different threshold. But all you can do when you go into GPU tweak is open it up and say, yes, warn me or don't warn me. And that warning means whether or not it pops a message up on the screen, not whether or not that light blinks. That light is always going to blink because that is a hardware warning and it is doing that on its own independent of any software. But that's what you need. You need some more indicators now because most people's indicator is, you smell that? That's and then black screen. And that's exactly what happened to us. It went black screen. And everything was still running and on. And it was when I went to unplug it that it would not come off. I literally had to use a lot of force. And it's crazy because it's not melted very badly. And it still took that much, like a lot of force to break the plug free. I expected it to look like one of those mangled plugs where when I send it in to get it repaired, I'm gonna have to send the adapter attached to it because it's not coming off, but I got it off, so. All right, well, there we go. I'm gonna now investigate and figure out why pin 1 is only pulling 7.74 amps and not the 8.5 or so it's supposed to be pulling. I might end up switching out the cable now for that very reason. But that's the cool thing about this design. And again, this is not sponsored by Asus. I just think this is a cool ass design that should exist on any 80 or 90 series tier card. This alone is not worth the $1,300, honestly. A premium above the cost of the card. There's a $1,300 graphics, or excuse me, $3,300 graphics card with the MSRP of $2,000. And I don't think it costs that much to design this circuitry. But you've got other $3,000 cards out there like the MSI Supreme and the Aorus Master and all that, which cost $3,000 on their own, but they don't have a design like this. So I like this design. I just thought I would share it with you guys. The fact that you can even monitor it visually with a sensor panel is pretty awesome. Any sensor reading software will see it. I thought initially when the card first came out that it was only gonna be visible to like GPU tweak, but it's not. It's visible to any monitoring software. That's AIDA64, you're looking at it right there. So, all right, it's pretty cool. It sucks that I had to kind of put it on hold. I've got a half a tank of 200, I got a 230 liter tank of LN2 that I'm gonna send back to West Air because it's gonna be a while before I can get this fixed, so. Oh well, second place will have to wait, I guess. And if you guys have been on my heels, you got some time because I gotta now wait until it's fixed and I'm not gonna try it myself. All right guys, thanks for watching. Just wanted to share something neat with you. As always, we'll see you in the next one.